If you're a sports fan, you've heard of a player having a hot streak. This is probably nowhere more apparent than in basketball, where the pace of play is constant and fast paced. For example, if a player makes multiple 3 point shots in a game, commentators and coaches are likely to say the player is on a hot streak. It appears to anyone watching that the player is operating at a higher level than their norm. But here's the problem: the statistics don't back this up. In Chapter 10 of Thinking Fast and Slow by Daniel Kahneman, he cites research that studied thousands of sequences of shots from the field and from the foul line, and they are shown to be statistically random. The illusion of a pattern is emotionally compelling, but the numbers don't lie. There is no statistical mathematical basis to support the claim of a hot streak in sports. It is just a very compelling myth and invention of our minds. To illustrate, let's look at a few examples to show how our minds distort small sets of numbers and draw wrong conclusions. First, consider this. A study of the occurrences of kidney cancer across 3,141 counties in the United States revealed that the lowest per capita incidence rates occurred in sparsely populated rural areas. Now, knowing this, your mind has been busy formulating a hypothesis. It probably went something like this. People in rural areas probably have a cleaner lifestyle, less pollution, more fresh food, less city stress. So, of course, they're healthier. Fair enough, but now consider this. The same study showed that the counties in which the incidence of kidney cancer is highest is also in sparsely populated rural areas. Now, your mind might jump to another set of inferences, which is that people in rural areas may have less access to healthcare, may be more likely to smoke and drink, and therefore are less healthy. But beyond the inferences our minds make to create a story of causality, let's think about the numbers themselves. The same study showed that the lowest and the highest incidence rates of kidney cancer were both in low population areas. Why? It is what statisticians call sampling error. Anytime a sample is too small, you get exaggerated results. When you measure a phenomenon across a larger population or set of numbers, you are far less likely to have extremes in one direction or another. The reason this study shows the highest and lowest incidence rates of kidney cancer is because each county represents a very small sample set. Let's demonstrate. Imagine that Jack and Jill each have a jar of red and white marbles. They are each told to randomly draw a number of marbles from their jar. For each draw, Jack draws a set of 4 marbles, and Jill draws a set of 7. Then they are each told to track how many times they draw a straight set of red or white marbles. Now, who do you think is more likely to draw a straight set of all white or all red more? Jack or Jill? Well, Jack, of course. The fewer marbles there are to draw, the more likely we will see a homogeneous result. It isn't because Jack is on more of a hot streak than Jill. It is because of the laws of randomness and statistics. In fact, mathematically speaking, Jack will draw a straight about 12.5% of the time, and Jill will only draw a straight 1.56% of the time. Jack will appear to be on a hot streak 8 times more than Jill. This example reveals the truth about kidney cancer in small counties. The only reason we see extreme results in small counties is because they are small, not because of healthcare, smoking, drinking, or stress. It is just pure statistics. We'll do one more example to underscore the point. Take a maternity ward at a hospital and imagine that there are usually 6 births a day there. One day the sequence is boy, 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 girl, girl, girl. The next day the sequence is girl, 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 girl. And the final day the sequence is boy, girl, boy, boy, girl, boy. Now, statistically speaking, are each of these 3 sequences equally likely? Your first reaction is probably no way, but you would be wrong. Statistically speaking, each one of these sequences is equally likely because each birth is independent of the other. Only the last sequence appears to be random, but the truth remains. They are all random. The math is terribly clear, but our minds are not. We are pattern seekers and storytellers. Our minds leap to causal relationships where there are none because our minds are not statistical computers. We manufacture meaning where there isn't any because we don't understand randomness and we find it unsettling. It is fun to perceive that a basketball player may be on a hot streak in a particular game or set of games, but really all we are seeing is a small sample set with extreme outcomes, like the marble game or the kidney cancer study. Sorry, sports fans, but the hot hand, hot streak myth, it's all in your head. It is just an illusion.